Hello. Um, Today we'll learn how to calculate mix variances and yield variances. The questions which we will be taking up from are from the exam kit Kaplan series, okay, Kaplan material. From that, let's take up the questions which are under mix and yield variances. First, we will learn about how to calculate mix variance. After that, see all questions on mix variance we'll answer one by one. After that, let's also take up yield variances in the same video. So coming down, first, of course, there are the heading is mix and yield variances, but we also do see that there is an operational and planning variance question given here. This is planning variance. So planning and operational variances, we will do it in the next video. But right away, so we'll start with yield and mixed variance. First, we'll do mixed variance. So question number 188 is on material mix variance. Let's take it up first. This question. The question says JC Limited mixes three materials to produce a chemical SGR. The following extract from a standard cost card shows the materials to be used in producing 100 kgs of chemical SGR. Then the three different ingredients or materials that are used are material A, B, C. First, let's look into that. When do we use a mixed variance? Now, variance, um, when we are calculating, we would have first the cost variance. Cost is basically made up of two components. One is if we are talking about material cost variance, cost is calculated based on the quantity that is consumed and the price at which this quantity was acquired. So we have standard cost of material minus actual cost of material gives us the cost variance. Now, because this is made up of two things, that is, one is price component and the other one is quantity component, we have material cost variance split into material price variance and material quantity variance, or we also call this as material usage variance. Okay, so how much quantity was initially planned and how much quantity was consumed. So that is basically the variance about quantity variance. So it is not always that one type of input is used and output is extracted out of that. Sometimes we also see that more than one type of raw material or input or ingredients components are used to produce the final output. Now, in that case, now every type of material that is consumed, what is the original planned one? So, how much was it planned to be consumed? How much was actually consumed? So, in that aspect, we also need to look into that. So, then this quantity variance, we also see that it is split into two parts. One is material mix variance. Mix is about the different types of raw material or the quantity that was consumed. So material mix variance, and because of these type of quantities that are used, how much yield was actually generated. So yield variance, when I start in the same video, I will be talking about that. So we can look into the explanation about what is yield variance. So now here we are at this point of material mix variance. So we see that in this question, JC Limited, there are three different types of material. Material A, B, C. Okay, material A, B, C are used to produce chemical SGR. Done. The standards are given as to produce 100 kgs of chemical SGR. This is how the raw material is consumed. 50 kgs of A, 40 kgs of B and 20 kgs of C. And we also have the standard rate and the value, the standard cost is also mentioned. After that, continuing in this question, it says that during October, 23,180 kgs of SGR were produced using the following material. So we see the actuals that have happened. The actual production is 23,180 kgs of HCR were produced and the cost structure is also given. We are asked to calculate what is the total material mix variance. Okay, material mix variance. See, when we talk about cost variance, we talk about the standard cost minus the actual cost. That is how material cost variance is calculated. And what is cost? Basically, cost is the quantity into the price. So we have split into two parts. The variance could arise on account of variation or variance in the price or variance in the quantity. So if we are talking about price variance, we would have the difference between the standard price and the actual price. Easy to remember. So we would have here as standard price minus the actual price. This is applicable at the entire actual quantity that is consumed. If it is quantity variance, so it would be the difference between the standard quantity and the actual quantity applied at the standard rate. So here we would have it as standard quantity minus actual quantity applicable at the standard price. Now, having said that, the variance between the standard quantity and the actual quantity calculated at the standard price or the standard cost when it is calculated, that is the quantity variance. But we see here in this particular scenario, there are three different types of quantities or quantities of material, three different types of material, and the quantities are also mentioned. Now, in this case, can we calculate it only by using one formula? No, we need to look into three different types of material and the mix what is given and the difference in the mixes, that is the standard mix and the actual mix also has to be taken into account, and then the variance is calculated. So I'll solve this question in Excel sheet. Okay. I'll take you to Excel sheet. From there, we'll proceed further. We are now calculating what is total material mix variance. So this question is pasted here in Excel and it says that there are three different types of material. Done. Three different types of material. The standards are given for 100 kgs of the chemical SGR. Actuals happened at 23,180 kgs of SGR. So now both of them are not on par that we can straight away directly compare them and calculate. What has to be done is the standard which is given at 100 kgs of output now has to be adjusted according to 23,180 kgs of SGR. That's the actual output that is produced. So let's start calculating the material mix variance. This is question number 188 from the latest version, that is 23-24 version. Now we are answering material mix variance. Done. The details that are given. So when we talk about material A, then we have B, then we have C. Done. The actual quantities are given, the how much quantity was consumed. So let's start with the actual quantity. Of course, in any order we can write, we can talk about the um, standard details first and then actual details, or it is advisable that we first start writing about the actual quantities because the standards have to be adjusted according to the actuals. So the details are given as 13,200, then we have it as 7,600 and 5,600 for C. When we total it up, then we see that the total amount is 26,400. 26,400 kgs of input when it was consumed. The output that is generated is 23,180 kgs of output. So the total input of material is 26,400 of all three types of material, material A, B and C. We now have to adjust the standard quantities because standard quantities are given for an output of 100 kgs. Now we need to know what is the standard quantity according to the actual output. So for that reason, step number one, you can remember that. Take total standard quantity equal to total actual quantity. So what is total actual quantity? We say 26,400. So 26,400 is the total standard quantity. Now that's fine, but what is the proportion in which we would have material A, B, and C? The proportion would be the original quantity composition that is mentioned. In the same ratio, we would take and um, allocate the amount of 26,400 among A, B, and C, or the composition of material A, B, C for standards will be in the ratio of 5 is to 4 is to 2 for the total quantity of 26,400. What is 26,400? That's the total actual quantity which is consumed. Done. Now, proceeding further, so it should be in the ratio of 5 is to 4 is to 2. 5, 4 is 9, 9 plus 2 is 11. So, in the ratio of 5 is to 4 is to 2, we are now going to allocate the amount of 26,400 among ABC, or calculate the quantities of standard quantities of material A, B, C in the ratio of 5 is to 4 is to 2. Okay, so is equal to 26,400 into, you can check the formula in the formula bar. This is the formula bar. See, if while typing, if something is disturbing you, you can follow what is being typed in the cell here in the formula bar. Done. Into 5 divided by 11. Okay. After that, we have for the next one 26,400 into 4 divided by 11. Then we have is equal to 26,400 into 2 divided by 11. Okay. So now that's the standard, total standard quantity. Now basically what is quantity variance? Quantity variance is the difference between the quantities. Okay. Of course, here there are more than one type of material, but nevertheless, it is still about the difference in the quantity, standard quantity and actual quantity, applicable at the standard price. Okay, step number two, we just have done step number two. Calculate standard quantities in the ratio of standard quantities given. Calculate standard quantities per mix in the ratio of standard quantities given. Here in this case, it is 5 is to 4 is to 2. Okay. Now what are we to do? Take the standard rate. What is standard rate? Standard rate is 10, 5 and then 9. The material mix variance is equal to, we see standard rate into, now it is about standard mix minus actual mix, or standard quantity minus actual quantity. Since we are individually doing it for each one, we would be talking about standard mix and actual mix. Okay. You can also write it as standard quantity and actual quantity. See, we don't, while doing the calculation, we do not write the negative sign, but see, whatever is the result of the calculation, we just have to mention it whether it is adverse or favorable. Okay. The rule is, in case of cost variances, when the actual quantity or actual cost or actual price is higher than the standards, it will result in an adverse variance. Else, if actuals are less than the standards, then it will result in a favorable variance. So we will just be careful about, since we are doing it in Excel, we will be careful about looking into that. It doesn't result in a negative sign. That's it. We don't write a negative sign, but But yes, we write it whether it is an adverse variance or a favorable variance. Okay, let's go according to what is the calculation. But wherever a negative value comes, we'll just do some adjustment. The formula goes like this, is equal to, we have standard rate given in this particular cell. Okay, click there, into, in a bracket, the standard quantity minus the actual quantity. Done. Okay, negative, wherever negative sign is there, we will make an adjustment here. Just drag this one down. Okay, when there is a negative sign, here in the equation, put a negative sign there. So that negative thing is not seen, but we will be writing the result of that. Now we need to mention whether it is an adverse or a favorable. Okay, what's the rule? When the actual is greater than the standard, it results in an adverse variance. Done. If here the actual quantity is 13,200, standard quantity is 12,000, it is greater than the standard quantity, therefore it results in an adverse variance. So we are writing it here adverse. Now for material B, actual quantity is 7,600, standard quantity is 9,600. So actual is less than, actual consumption of material is less than the standard quantity. So it is a favorable variance. And the last one is an adverse variance. None. So now just we need to total it up. Okay, total it up is, see there are two negatives and two adverses and one favorable. So here we would write it as is equal to all the adverses, take them up, add it up and deduct the favorable ones. So this is 9,200 adverse. 9,200 adverse, which is option C. Okay, so the third step is just apply the formula. What's the formula? Material mix variance is equal to standard rate into standard mix minus actual mix. If you remember these 3 points, these 3 steps, it's very easy to calculate material mix variance. So let's also solve another question on material mix variance. I'm taking you to the exam kit. We have 189 and 190. Those questions are also there, but another one, a similar pattern style of question, we'll take it up as 191. After, as soon as we finish 191, we'll go to 189 and 190 and then solve them. 191 question. Okay, the question also looks similar to the previous one, the one which we have just now solved. Question number 191 says that a company has a process in which the standard mix for producing 9 liters of output is as follows. So we see that 4 liters of D at the rate of $9 per liter, $36, and similarly for E and F also the details are given. Then we see that a standard loss of 10% of inputs is expected to occur. The actual inputs for the latest period where we have the actual quantities given as 4,300, 3,600, 2,100, and the costs are also mentioned to us. Actual output for the period was 9,100 liters. Done. What is the total material mix variance? So total material mix variance, we see that there are 3 different types of material, D, E, and F. Okay, they are all given for an output. Okay, standard mix for producing 9 liters of output. Okay, the actual output is given at 9,100 liters. Okay, the total quantity of standards is given as 4 plus 3.5, 7.5 plus 2.5. This is the total quantity for producing 9 liters is given as 10. But we see the actuals are at different level. So we see that this is because the output is 9,100. The quantity consumption also is at a different level. So we need to take the total actual quantities, equate that to be standard quantity. And then in this proportion, divide that, and then I have pasted this question in Excel sheet. So let's go to Excel sheet to solve this particular question. I hope you remember the three steps. Let's take these three steps. It becomes easy for us to remember. This is question number 191. Let's solve question number 191. Done. How many types of material? We see material, we have first D, then we have E, then we have F. What do we start with? We start with actual quantities. The actual quantities given are 4,300, then comes 3,600, then comes 2,100. Add them up. The total actual quantity is 10,000. The same is the total standard quantity taken. That's step number one. Take total standard quantity equal to total actual quantity. But the proportion would be in the ratio of the standard quantities that are given, which are given as 4 is to 3.5 is to 2.5. So which will be now standard quantity for actual mix will be is equal to 10,000 into 4.5 divided by 10. The total parts 4.5, 3.5 and 2.5 is 10. Okay, so it is, this is just 4, not 4.5. I'm really sorry. This is 4. So this is 4,000, then 3.5 is equal to 10,000 into 3.5 divided by 10. And then here is equal to 10,000 into 2.5 divided by 10. Done. Write the standard rate. Next one, take the standard rate. Standard rates given are standard rate 9, 5 and 2. Okay. Material mixed variance is equal to, we have it as standard rate into standard mix minus actual mix. Okay, apply that rate is equal to 9 into standard quantity minus the actual quantity. Okay, drag it down. We will be adjusting the negative signs. So when this is a negative sign, just put after is equal to put a negative sign so that we don't show a negative value while writing the value. But yes, we do have to also mention whether that is an adverse variance or a favorable variance. The rule is when the actual quantity exceeds the standard quantity, it is an adverse variance. Okay. Here, the standard quantity is 3,600, actual quantity is 3,500. So, this one also is an adverse variance. The next case for material F, we see that it is 2,100 and 2,500. Actual is less than standard. So, this becomes a favorable variance. Done. Now, we need to write the total. The total is, take all the adverse variances, add them up. From that, deduct the favorable ones. Done. So that's 2,400. We see that it is 2,400. Since the adverse are greater than the favorable ones, So overall it is 2400 adverse. So for this one, we have the first option, option A, 2400 adverse as the answer. Okay. Let's also quickly solve one more question on material mix variance to have a better hold on the content. See, we have questions 180, 189. That's also a material mix variance. So let's solve this one quickly. So I'll bring the rules, three rules here and paste it here so that we can have a look at this one. The rules are take total standard quantity equal to the total actual quantity. Putting them here. This is question number 189. We see materials are material. Okay. Let's read the question first. I think then we'll have a better understanding about what is the data. Question number 189. Mr. Green makes salads. The standard plate of salad has 30 grams of lettuce, 50 grams of peppers, and 80 grams of beetroot. The standard prices of the three ingredients are 0.2 per kg, 0.4 per kg, and 0.8 per kg, respectively. The actual prices were 0.22 per kg, 0.38 per kg, and 0.82 per kg. Mr. Green has been experimenting, and so in July he changed the mix of vegetables on the plate. Thus, 1,500 plates contained 62,000 grams of lettuce, 81,000 grams of pepper, and 102,000 grams of beetroot. What is the value of total favorable material mix variance? Okay, let's go to the Excel sheet and then so the ingredients we have them as there are three ingredients that are used. One is lettuce, then the other one is pepper, and we have beetroot. Now, the actual quantities given are see to make an output or to make 1,500 plates. The requirement of the ingredients are lettuce is 62,000 grams of lettuce was used, 81,000 grams of pepper was used, and 102,000 grams of beetroot was used. So the total actual quantity is 245,000 grams. Done. After that, when we look at the standard quantities are given for making one plate. The standard plate of salad has 30 grams of lettuce, 50 grams of pepper, and 80 grams of beetroot. So, when these things are given per plate and the actuals are given at 1,500 plates, we need to adjust the standard quantity according to the actual mix. So, step number one is we will equate this to be 245,000. Done. The mix will be in the ratio of, see the quantities that are mentioned are, we have 30 grams of lettuce, 50 grams of pepper, and 80 grams of beetroot. So the ratio will be 3 is to 5 is to 8. Okay. 3 plus 5 is 8. 8 plus 8 is 16. Okay. Total 16 parts is equal to 245,000 into 3 by 16 is equal to into 5 divided by 16, and then we have it as is equal to 245,000 into 8 divided by 16. Standard rates. Write the standard rate. Standard rate given is, see, the quantities are given mentioned in grams, but standard rates are given per kg. In a kg, there are 1,000 grams. So now we need to be careful while writing the standard rate. Standard rate is given as 0.2 per kg. If we are to make it per gram, so this will become is equal to 0.2. In a kg, there are 1,000 grams. Okay. Be careful about that and then write it. Is equal to zero point 0.4 divided by 1,000. Here we have it as 0.8 divided by 1,000. Okay. So now what is material mix variance? Material mix variance is equal to, we have standard rate into standard mix minus actual mix is equal to, this is the standard rate into, in bracket, the standard quantity minus the actual quantity. We will also adjust it for the negative values. So when the actual quantity exceeds the standard quantity, in that case, we have it as an adverse variance. Here also, this is 81,000 versus 76,000. So this is again an adverse variance. But the last one, 102,000 and 122,500. So this becomes a favorable variance. Done. Overall variance is equal to, take the adverse variances, add them up, and from that deduct the favorable variance. Okay. See, we see that favorable variance is only higher than the adverse variance. So other way around, we'll do it. Take the favorable variance, okay, minus both the adverse variances. Okay. This is a favorable variance. We need to fill this in the box 11.41. Okay, here there is no multiple choice option given. So we need to write it as 11.42, as many number to the nearest cent. So round it off to 11.41. Since it's already mentioned that it's a favorable variance, if we write it as 11.41, that would be fine. Okay. I hope that is clear. So there are three steps we need to remember. The actual quantity, start with that. Take the total standard quantity equal to the actual quantity. Find out what are the components in individual ingredients or material or component. Find out the standard quantity in the ratio of the standard quantities which were earlier mentioned, and then apply the formula. Okay. Let's continue with yield variance. So now let's continue with the yield variances. This is question number 186. See, we did look into the classification of material variances. Material cost variance is divided into price variance and quantity variance. Quantity variance is divided into mix variance and yield variance. The actual formula of yield variance, I am taking you back to the Excel file. So when we talk about material yield variance, it would be standard rate. I'll explain about what is the concept of standard rate into the standard yield minus actual yield. Yield is the output basically. So when we have the yield variance calculated, it should be a comparison of what's the standard yield or the standard output versus what's the actual yield or output applicable at the standard rate. Wow. Okay, so there's a question here, question number 186. Um, Question number 186 says, Product GX consists of a mix of three materials J, K, and L. The standard material cost of a unit of GX is as follows. So the the standard material cost of a unit. So the details of standards are given per unit. Done. So J, K, L and the quantities are given, the value is also given. After that, we see the during March, 3,000 units of GX were produced. So this is the actual yield were produced, and actual usage of the quantities that were consumed to produce 3,000 units of GX are given as follows. And the question says that what was the material yield variance? Okay. So now if we are asked to do this one, see material yield variance as I have written just now, it is a comparison of the standard yield and the actual yield applied at the standard rate. So it would be standard rate applied at for the difference of standard yield minus actual yield. Okay, this part of it actual yield is given in this question, which is given as 3,000 units. Done. But there is no mention about what is the standard yield. So for one unit of standard product GX, this is the consumption. So there is another way we can approach yield variance in terms of how much is the usage of material. Usage of material to produce this yield which is 3,000 units. So material yield variance can also be calculated as standard rate into the standard usage minus the actual usage of material for the actual output. In terms of usage of material, see, more is consumed, it is not a favorable thing, it is an adverse thing. Less is consumed, it is a favorable thing. So that with that logic also we can apply this material yield variance. Yield is basically output. Since we do not have the standard yield mentioned about, on par with the actual usage, the standard details are given per unit. Therefore, what we do is we proceed further in terms of doing material yield variance as how much material was actually consumed, consumption. Based on consumption also, material yield variance can be done. So let's go back to Excel sheet and then from there we'll proceed. So this is the data. We see that material, there are three types of material that are consumed. We have J, K, and then L. Done. The actual quantities, actual usage, basically I will write it here as usage, consumption. They are given as 13,200. Then we have 6,500. Then we have 9,300. The total actual consumption or usage of material is 29,000. Standard consumption is given per unit. One unit consumption is 5 kgs, 2 kgs, and 3 kgs. So, standard quantity, that is usage for 3,000 units of output. So, if 3,000 is the output, we would have it as is equal to 5. 5 kgs is what is required for producing material J. 5 kgs of material J is required to make 1 unit of GX. So 5 kgs into 3,000. Done. And then the other one is equal to 2 kgs into 3,000. And then we have it as 3 kgs into 3,000. Done. Add them up. So the consumption is 30,000. The actual consumption is 29,000. The standard consumption of material is 29,000. Now, done. So we can also calculate material yield variance. Material yield variance is equal to standard rate into standard, I'm writing it here, standard usage of material minus actual usage. So more is consumed, less is consumed. With that perspective also, we can proceed further. Okay, that's all fine. Standard usage, we have the actual usage 29,000, standard usage is 30,000. But what about standard rate? Since we have three materials and three different rates are given, how would we proceed further? So the way we proceed further is, see, we have the details given as standard quantities are given per unit. So, and the standard cost is also mentioned to us. Standard rate, then in that case, instead of proceeding, because the formula is one formula, standard rate applied into the total standard usage and the total actual usage. So we need to have one standard rate. Standard rate will be, then in that case, it is weighted average standard rate that is calculated. So weighted average standard rate, how do we calculate that? Okay, so the total standard costs are given as 20, 24, 24. The standard quantities are given as 5, 2, 3. So we can also have it here. Standard quantities are given as 3, sorry, 5, 2, 3, and the standard cost is also given. So standard costs are given as 20, 24, and then 24. Just add them up. Standard rate would be standard cost divided by standard quantity. Done. So this will be weighted average standard rate would be 68 divided by 10, which is equal to 6.8. Fine. Now we just have to find out what is material yield variance. Material yield variance is equal to 6.8 because standard rate is 6.8. 6.8 in bracket. The standard usage is 30,000 minus the actual usage, which is 29,000, is equal to, let's substitute the data, which is equal to 6.8 into standard usage 30,000, actual usage is 29,000. And is it favorable or unfavorable? The standard usage is 30,000, but the consumption was only 29,000, less was consumed. So on that note, this becomes a favorable variance. So 6,800 is favorable. Option A is the answer, 6,800 favorable. I hope that's clear. Alternatively, we can also use another formula which says that material yield variance is equal to, so we'll see how to apply this one as well. Material yield variance is equal to standard rate into standard yield minus actual yield. So now if that is the case, how do we apply this particular formula? So let's just check this one. Now, when we are talking about yields, we already know that actual yield is equal to 3,000. That's the actual output that is produced. Now, there's no mention about standard yield, and standard yield, if it has to be calculated. See, we see that 29,000 kgs of actual quantity of material was consumed for making 3,000 units of GX. That's the actual consumption. If the standard quantity also is taken to be as 29,000, with 29,000 kgs of standard quantity, how much would be the output? So that's the logic. Let's say that actual quantity, we do see that it is 29,000 kgs. Okay. By using 29,000 kgs, the output produced is 3,000. That's all fine. Now let's say standard quantity is also taken to be as 29,000 kgs. Now with 29,000 kgs, how much would be the output? Now this is input. In terms of input, we are talking about uh, quantity of material that is consumed. Then output, if we talk about, now for the standard quantities, 10 kgs of input is required to make one unit of the output. The standard material cost of a unit of GX. So for 1 unit, the total quantity that is consumed is 10 kgs. We do see this one. To make 1 unit, 10 kgs of material. Fine. If that logic is applied, if we apply the same logic and then work it out, so standard quantity to make 1 unit of an output, it requires 10 kgs. So by taking 29,000 kgs, how much will be the output? So that way we can calculate the output as, here I'll put this one is equal to 29,000 divided by 10 kgs of uh, quantity. So 2,900 units of output. So standard yield is 2,900. I hope once again I will explain this part of it. See, the actual quantity is 29,000. So actual quantity is 29,000, which is used to make 3,000 units of actual output. Done. We do not have the standard yield, but we just understand that to make 1 unit of output GX, 10 kgs of material is required. Okay. If we take the same 29 kgs of input as is the consumption of actual quantity, the same quantity when we take, how much would be the output? That is what we basically have to calculate. Now, what is the logic? To make 1 unit of GX, 10 kgs of material is required. By using 29,000 kgs of input, how much would be the output? It would be 2,900 units. Done. Now, what is material yield variance? Let's also now calculate what is material yield variance. So the formula goes like this. Material yield variance is standard rate into standard yield and actual yield. So standard yield is 2,900, actual yield is 3,000. What about the standard rate? Now, what will standard rate be? Standard rate is the standard cost to make 1 unit. Standard cost to make 1 unit of the output is 68. That is the standard rate. Done. So now we just have to apply material yield variance. Material yield variance is equal to standard cost of making 1 unit is 68 into the standard yield is 2,900 minus the actual yield is 3,000. Done. So that will be is equal to, we have it as 68 into, in brackets, we have it as standard yield is 2,900 minus actual yield is 3,000. Done. Now 6,800. Now it shows a negative sign, so I'm just adjusting it here. Okay, 6,800. But 6,800, is it favorable or adverse? Now this here it is yield. Yield is output. Output. Now when we are talking about output, when the actual output is greater than the standard output, there is a beneficial situation or it's a favorable situation. So automatically this becomes favorable. Okay. So this is 6,800 favorable A. So there are two ways of doing, whichever way you feel comfortable, you can use that and then arrive at what is material yield variance. The first one is based on the consumption. The second one is based on the yield. So yield would be, so when the quantities are taken to be the same, 29,000 quantity, 29,000 quantity or the input. If the same input is used for standard, how much would be the output? So we have worked out on that and then yield. So to make 1 unit of output, standard output, the standard cost is 68,000. That becomes the rate 68 into 2,900 minus 3,000, 6,800. Either ways, whichever way you feel comfortable, you can use that and apply it. I hope that is clear. To continue with, let's answer question number 190. What is the total material yield variance? Now that we have learned two methods, so we'll apply the second method in terms of calculating material yield variance, a comparison between the standard yield and the actual yield applied at the standard rate. So this is the question which Mr. Green's question, make salads. This one we have answered material mix variance, the same data set. Now we have to answer this question for material yield variance. Okay, the question goes like this: Mr. Green makes salads. The standard plate of salad has 30 grams of lettuce, 50 grams of pepper, and 80 grams of beetroot. The standard prices are also given. After that, Mr. Green has been experimenting, and so in July, he changed the mix of vegetables on the plate. Thus, 1500 plates contained 62,000 grams of lettuce, 81,000 grams of pepper, and 102,000 grams of beetroot. What's the total material yield variance? So let's answer this one in Excel. Okay. So now we do know that there are three ingredients. We see lettuce, pepper, and beetroot. Now we are now going to apply the second formula. The second formula of material yield variance is equal to standard rate into standard yield minus actual yield. So we do know that standard rate should be calculated based on whatever is the data or the standard cost of making one plate. Here in this question, we see that the standards are given per plate. So for one single plate, 30 grams of lettuce, 50 grams of pepper, and 80 grams of beetroot. The rates are given per kg, but the quantities are given in grams. So we need to be careful. Already we have applied this when we were calculating material mix variance. So let's take that very carefully about what those quantities and rates are. So now standard quantities are given as 30 grams, 50 grams, and then 80 grams. Done. Then we have standard rate. Standard rate. So we need to find out what's the standard cost. Standard cost per plate is what we need to find out because we have to apply what is standard rate. Standard rate here is standard cost of 1 unit of output. And just multiply these two. And then find out the sum total of it. So this becomes standard rate per plate. Standard rate per plate is 0.09. That's fine. We do know what is actual yield. Actual yield is given as, this was all for making 1,500 plates. Done. But we do not know what is standard yield. Standard yield has to be calculated. So for every one plate, 30, 50, 80. These are the quantities that are consumed. Done. Now, when the standard quantity was equated to 245,000 grams, with 245,000 grams, how many plates can be made? That is the logic what we are applying here. See, the total quantity, this total standard quantity, which was taken as the total actual quantity equated to total standard quantity, with 245,000 grams of total quantity, how many plates can be made? That's the logic. Okay. Now let's calculate what is standard yield. We see that, see, 30 plus 50 plus 80 comes out to be 160. So 160 with 160 grams, we see that one plate can be made. So now with 245,000 grams, how many plates can be made. Okay. We see that 1531.25 plates can be made with the total quantity of 245,000 grams. So 160 grams is 30 plus 50 plus 80 is 160. With 160 grams, one plate can be made, that is given as standard. The standard plate of salad was 30 grams of lettuce, 50 grams of pepper, and 80 grams of beetroot. So when the total standard quantity is taken as 245,000 with 245,000 grams, how many plates can be made is 1,530.25. We just have to substitute the values here in material yield variance. Standard rate, we have it as 0.09 per plate. So here it would be per plate output, okay, into the standard yield is 1531. Either ways we can write it. It is only about the logic what we apply here, 2.8125. So will this be favorable or adverse? The standard yield is 1531. Actual yield or actual output is 1500. Actual yield is less than the standard yield. Therefore, it would be an adverse variance. So 2.8125 adverse is the answer. That's option B. I hope that's clear.